At an automatic changeover switch. Well, it doesn't say automatic in the title, but I think in later models they did call it automatic. It's a model 3257A. It's made by Grass Valley. Very, very simple device. Let's go ahead and take a look at the back side here real quick. Got a number of inputs, A and B, and outputs. What's a little interesting is we got, I believe, 9 inputs per channel and only 7. Oh, I cannot count. There are 9 outputs. Okay, that makes a lot more sense. Earlier I thought there were only 7 outputs, but there were 9 inputs. I was like, what happened to 2 of those? Okay, I feel a lot better now. Back on the front, take a look here. We got very basic controls. You have indicators that show whether you're on input A or B. You can select input A or B, a manual failover, have a fault light saying something's wrong, and you can reset that fault. Maybe, if you're lucky. Okay. Yeah. Open it up here. Got a pretty simple setup. You've got the power supply, the logic, and the actual changeover unit. And you can push that and it moves. So, and also manual or automatic switch here. Let's go ahead and plug it in. Let's see what happens. Okay, so sounds like it just actuated once. Let's see, we're on input A. We have a fault, and it won't let us reset it. There's no inputs on here, so I'm hoping that's why. Seems logical. Now let's switch to B. Okay, we're on B. And that little... This is not the correct power light in here. It's just kind of floating in the breeze. And if we switch to manual, I don't know, obviously nothing different's going to happen here. But yeah, so let's go ahead and pull these out and take a closer look at these boards. Our first board here, here's the first board. It's a power supply. Wonder of wonders, it's a very basic linear power supply. Got some rectifiers here, got capacitors, and a little flat transformer. Pretty basic. Next thing we got is the actual logic. A lot of the components on here, I believe, are from the 70s, giving you an idea of how old this design is. In the center, we have some switches and a list where I guess you'd say what each function is for, which is a bit odd because you would think you would know what that's for, but maybe these are assigned to, if we come over here, you can see that we have, looks like 8 channels here, or we have 9 adjustments. So not exactly sure what's going on here. Maybe this says only check this and fail over if one of these goes below a certain level. Obviously, the scarcity of components here makes me think that it's not actually doing anything particularly fancy other than just saying, is there a signal here or isn't there at a certain level? And maybe you can adjust that here. I don't have a manual for this, so I'm not really sure actually how to use it. And in fact, all the inputs on the back are labeled J1 through whatever, so if they had a specific purpose, I don't know what they are. Usually, this equipment would be used to automatically switch between like a house sync or some sort of video source to, if one of them failed or you needed to work on one sync generator, you could take it out of service just by flipping the switch, or it would automatically fail over if one died. So it's a pretty small use case, and but I believe you could adapt it for any situation where you needed to have redundancy. So if we take a look here, we've got some 555 timers. Interestingly enough, this is made by I think it's American Machinery, and I can't remember, AMF. You normally see that in bowling alleys, but they actually did plenty of other things as well. So I think this is just a relay. You have some comparators here, and I think this is another. Yeah, this is a 741. That's pretty common, but this is a 3403. Got a couple of those here, and then we have local power supply regulation here. This is actually brings it down to the voltage that it should be. I have a hybrid here, or maybe just a resistor network, it looks like. Possibly laser etched, to be specific for something. I don't know why there's such a fancy resistor network on here, and a custom one at that. Grass Valley was really known for that. In fact, I think it was one of their marketing things is, hey, we can precision cut, with lasers. We can make these little hybrids and, save space and do all this custom stuff. And so you'll see a lot of that in Grass Valley equipment. I think I have figured out its secrets. If we take a look at the back here, zoom in a little, count the resistors, and there's only 8 of them. This 9th output is not monitored as far as I can tell. It may be, but it looks like it is not. If we move into here, we have, these are definitely adjustments for level checking on those 8 outputs. It actually checks the output. It doesn't check each individual input for sense. It just makes sense to me. And these switches right here determine whether or not it will check a certain input. Well, I seem to have killed it. Goody. Okay, well, I'm going to assume I shorted something out when I was moving it around. Anyway, can't demonstrate it working, but anyway, take my word for it. This just sets whether it's going to monitor that particular input. So we have 8 that we monitor, we have 8 switches, pretty easy. And this is just so you can write down, hey, that's what that switch is for. So, and the most interesting part of all, this thing is more like a pinball machine than anything. It's got this nice rotary switch here. Unfortunately, I took off the less interesting side, so you only see what are read switches. So you can see the loom. Here are the inputs and some more of the inputs and the outputs. And so when it rotates, there are magnets on a disc under here that are offset. So you have one set of magnets on here but none here, and then it'll shift that magnet over, and it just keeps ratcheting in a circle. So it just switches the set of magnets from one set of read switches to another, and it just flops back and forth every time you rotate. And I'm pushing, there's a manual lever on the front here to change it over. And right here is the solenoid. As you can see, some screws, and here's the drive for it. So as you can see, here is solenoid, and it will retract and then force the wheel to turn, and it'll park there. And this guy will hold it in place as well as this guy. Or, need to change over again, pull back, and come back into place. Pretty simple. So, I don't know if the camera will pick this up, but the magnet is here, here, here. So you can see where the reed switches are soldered. Those are the points there. And there's a magnet on this disc. All the way around here, there's one here, here. Okay. And so when you do this, all we do is take that magnet and it's coming along here to the next spot. Do it again, moves on to the next spot. It never goes back and forth, it doesn't oscillate, it just keeps rotating. So, very simple design. Yeah, I like it. If they put some more modern electronics in here, actually detect, you know, a sync signal and a gen lock, or a horizontal vertical drive, if that's in use, you know, actually detect if the proper signal is there, if it's dirty, rather than the presence of any electrical signal. So anyway, pretty neat. Thanks for watching.